And our session host is Will Srubar, who has been a key part of the Carbon Leadership Forum and the Embodied Carbon Network for a good long time. He's a professor in the Department of Civil, Environmental, and Architectural Engineering at the University of Colorado in Boulder. And I'll let Will introduce everybody else and take it on. Thank you.
Welcome, everybody. Thank you for joining us today for this session. We're hoping to continue the momentum of the conversations that we've been having this morning. So we're going to talk to you a little bit about best practices and tools for quantifying embodied carbon of every project. And I'm joined up here on stage by my three esteemed panelists that I've actually known for quite some time. So I'd like to introduce them. Kelly Roberts here is a principal and project manager at Walter P. Moore in Atlanta, Georgia. She has structural design experience ranging from educational and healthcare facilities to high-rise office towers. She leads Walter P. Moore's Sustainable Design Community of Practice for the Structures Group and specializes in whole building LCA. She is a founding board member of a nonprofit material reuse center, the Lifecycle Building Center of Greater Atlanta, as well as a member of the Structural Engineering Institute Sustainability Committee and the Carbon Leadership Forum. Kelly was recently named as one of the 100 most influential women by Engineering Georgia magazine. She is a 2017 Design Futures Council Emerging Leader and an Engineering News Record magazine top young professional. So welcome, Kelly. Stacy Smedley has a Bachelor of Arts in Architecture from the University of Washington and 15 years of experience in the architecture and construction professions. Her resume includes the first LEED for Homes Platinum certified project in Washington State, as well as the first project in the world to be certified under Living Building version 2.0 standards, the Birchie School Living Science Building in Seattle. At Skanska, Stacy fulfills pre-construction management and sustainability roles, focusing on creating sustainable initiatives and opportunities office-wide. She is a subject matter expert in green certifications and construction materials, from associated emissions to transparency and toxicity. Stacy is currently on the advisory board for the University of Washington Carbon Leadership Forum, chair of the Embodied Carbon Network Construction Task Force, and chair of the Washington Businesses for Climate Action. So welcome to Stacy. Thank you for joining us. And finally, Bruce King is a registered structural engineer with 30 years of private consulting experience and 25 years of leadership in the green building movement. He has served as a green clean tech advisor to numerous startups and other organizations. He has worked on high-rise structures in San Francisco, aircraft remodeling in Miami, Tahitian resorts, Buddhist monasteries in the Colorado Rockies, passive solar designs all over the world, and hundreds of houses of every shape throughout North America. He has lectured and taught ecological building practices in international settings. In addition to keynoting and speaking at numerous international conferences, he is co-founder and co-director of the Ecological Building Network, a nonprofit coalition of engineers, builders, and architects developing and disseminating best technologies for the built environment. He is also co-founder of Green Building Press, a small publishing enterprise, and he is the author of now 4 books, right, Bruce? 4 books, Buildings of Earth and Straw, Making Better Concrete, Design of Straw Bale Buildings, and the recently published New Carbon Architecture. Thank you all for being here today. So what I wanted to do first, because we come into this room with a lot of different experiences and perceptions of carbon and carbon emissions, and especially as they pertain to building and building projects. So what I wanted to do first is to create a baseline terminology of some acronyms that you're going to be hearing throughout the conversation that we're having in the next hour. So developing common language is very important, not only between each other, but also if we're trying to affect change. So I want to get on the same page. You will hear terms like embodied carbon, carbon footprint, greenhouse gas emissions, global warming potential, and we call that, that's the carbon that we're talking about. Embodied carbon, really is a quantitative metric of greenhouse gas emitted during the manufacture, use, and or disposal of a product or process. So it's most commonly reported as massive carbon dioxide equivalent or kilograms of CO2 equivalent. So when you hear embodied carbon, that's what we're talking about. Life cycle assessment is a standardized methodology by which we calculate and report embodied carbon along with other environmental metrics. So it's through this methodology of defining a goal and scope, finding data for the inventory, and conducting an assessment by which we establish and report those impacts associated with different system boundaries that we may be interested. So manufacturers may be interested cradle to gate, or if we're talking about an entire project, building project, over its entire life cycle, we're measuring and reporting cradle to gate grave impacts. The third is environmental product declarations. So EPDs are third-party verified published LCAs on either products or manufacturing processes. And go back a slide. There we go. Third-party verified LCAs for a product or, say, a manufacturing process. EPDs can be found in publicly available databases that are actually adding new EPDs virtually every day. And architects and engineers use this information to make environmentally informed decisions about the products they're using in their projects. And then finally, we have supplementary cementitious materials, which supplementary cementitious materials, or SCMs, are alternative cementitious materials that are used in place of cement. We heard earlier today that cement is very energy and carbon intensive to manufacture. And SCMs, like fly ash or slag, are commonly industrial byproducts that can enhance both the technical and the environmental performance of concrete. So you may hear these terms, a lot of acronyms, a lot of TLAs, like I like to say, three-letter acronyms. TLAs when our panelists are talking today. So I charged each of the panelists before this session to provide some answers to some very basic questions. So I'm going to let each of them talk a little bit about who they are, their organization, and why counting carbon is important to their organization. I'm going to have them talk about what barriers have they and their organization faced in advancing sustainability initiatives and how they overcame those. And I asked for them to provide an example of tools that they use to count carbon in their projects or in their products. So I will kick it off. I'll have Kelly kick off the conversation.
All right. Thanks so much for having us, and thanks, Will, for the introduction. So I work for Walter P. Moore. I'm a structural engineer, so that's where my perspective is coming from. I also practice in Atlanta, Georgia, and I do projects mostly in the Southeast. So that really also frames my perspective, so take that into account when I'm talking about barriers and hurdles. Your barriers and hurdles may be different than mine because I'm practicing in the South. We have 20 offices. We're an international firm of consulting engineers, architects, and designers. We have over 600 staff. And we do a variety of projects. We do everything from large, complex sports stadia to healthcare to park pavilions and libraries. So we really touch everything. Counting carbon is really important at Walter P. Moore because as structural engineers, we specify anywhere from 70 to 90% of the embodied carbon in a building, the structure in a new building. The structure accounts for a very large portion. It can vary kind of dramatically across different projects depending on the types of materials that you're using specifically for the structure. But the structure is really important when you're looking at the overall embodied carbon component. And as we all heard this morning, embodied carbon is becoming more and more of a focus in the world of sustainability. You know, for years, sustainability has really been focused on operational energy, and it needed to because, you know, traditional buildings, 80% of the energy was consumed by operations, and then 20%, you know, about was focused on embodied. But as we really have focused on that operational and driven those EUIs down, embodied has become a bigger piece of the conversation. The other really important part that was touched on today is the fact that all embodied happens at the very beginning of a project. So the day that you open those doors, all of the embodied carbon is there. There's a great white paper by Larry Strain on Carbon Leadership Forum's website if you are generally unfamiliar with the time value of carbon, but it speaks to that and how important it is to address that embodied carbon now. So we as structural engineers, we own that embodied carbon, and we know that that's our burden to tackle. And we're really focused on trying to reduce embodied carbon wherever we can on every single project. And you may not always hear about it on a project because it may not even be part of the sustainability conversation. Kind of jumping ahead to some of the hurdles, often structural engineers aren't even asked to join the sustainability charrette. We have to sometimes invite ourselves to be a part of that conversation. But despite that, we're still focused on looking at carbon in every project. One of the reasons that it's so important is that 5 to 7% of the world's global CO2 emissions come from cement production alone. Not concrete, just cement. So focusing on that one piece is really important. And if we focus on that one piece on every single project, it'll make a big difference. One of the challenges is of course, like I've mentioned, there's been a focus on operational. The other thing about operational is that the end user, they can see a difference. They can see a financial impact. They can save money by investing ahead on their operational. Whereas with embodied, it's difficult to see that return. It's difficult to see the good that they've done by focusing on the embodied. The other thing is that we can actually only do so much as structural engineers on our own. We can only refine that structure so much, optimize that structure, reduce the cement, look for alternatives. We can specify recycled aggregates or carbon sequestering aggregates or carbon cure. We can do all those things, but that only takes us so far. We're certainly not going to change an entire high-rise concrete office building to a wood high-rise office building on our own. We need buy-in from everybody. We need buy-in from the designers. We need buy-in from the owners. And there may be some financial investment to reduce that embodied carbon. Certainly, if we're going to get to zero embodied carbon, we're going to need buy-in from everybody. So those are some of the challenges. And then our tools, right? Okay. Okay, so this slide is showing a sample tally output. So some of the tools that we use to quantify embodied carbon on our projects are whole building life cycle assessment tools. So basically we use our BIM model, we use Revit, and we extract our quantities, and then we can use programs like Tally and Athena or One-Click LCA in order to do the whole building life cycle assessment. Tools that integrate directly into Revit have been really useful because we can kind of use it as part of our design process. It has made us make our Revit models much more intelligent. We're putting much more information into our Revit models than we used to. And we're going to continue putting even more information into our Revit models, mixed designs, how much cement, how many supplementary cementitious materials we're using for each concrete mix. All of that is going to be more and more integrated into our BIM models.
Great. Thanks, Kelly. I think next up we have Stacy.
All right, thank you. Can you just, I guess I now I can do it myself, which is what I was asking for. Oh no, it's the wrong side. We can, I think this will work. Okay, all right, so Skanska's story, we're a contractor, so we build things. And we're a very large contractor, we're international. We have 36 offices in the United States. We're based in Sweden, so our mothership is coming from the European progressive mindset. And I steal these slides with pride. I need Ed's new set as of this morning because he has better slides now. But I first heard Ed speak about 4 years ago and talk about embodied carbon. Skanska as a company has been committed to carbon reduction for 15 years now, starting in Europe. And about 4 years ago, when Paris was happening, we made a global commitment to zero carbon in our European market by 2050, and then setting reduction targets here when it comes to our construction practices. But embodied carbon was something that we had just touched and on a very small component of our work through our commercial development projects, where we're the owner, we could actually mandate that we track it and look at it. So when I started to see these kind of metrics and just the amount of stuff that we're building worldwide, Skanska decided that even the embodied carbon, even though we're not the ones specifying the projects or the owners telling us what we can put in the buildings, was something that we needed to quantify and aim to reduce. So we care about this because we are touching that 90% amount of stuff in the orange and the yellow. That's the embodied carbon footprint of things. We have an ability to take what we touch and reduce that number through education and engagement with our design teams and suppliers and subcontractors to work to reduce that. We can do energy models and costing on the operational side, but we touch all of those materials that we're talking about when it comes to embodied carbon. That's really why Skanska is focusing so heavily on that right now. Just a little bit about the challenges. When we started looking at embodied carbon, really just data. The challenge was understanding what it was and how to track and quantify it. So this is just an example of the carbon footprinting that we started to do on our own projects. We came up with our own Excel spreadsheet where we got data from Athena and Tally and some of those tools that were mentioned. And we just started tracking on our owner-developed projects, where Skanska was the owner, where the materials were coming from, using ticket receipts and quantities from our estimates to get those quantities into the system, but also looking at our construction impacts on site, how our employees were getting to site, all of those things. So we were able to do that for a very small building set. It was actually 10 buildings at the time, to create these kind of benchmarks and start to understand, based on what our buildings are made of, where the embodied carbon is actually coming from and how they're comparing to each other. And that was really valuable to us to start to understand in one market why Project C might have that much more embodied carbon when it's using the same type of materials as Building A. So the benchmarking and understanding of data to set targets and metrics was very important. And what that led to 2 years ago was Skanska using our own innovation grant money to feed an embodied carbon benchmarking study at the University of Washington Carbon Leadership Forum. And really this was to actually just increase that benchmarking that we were trying to do ourselves. This is an open source online study where you can go and actually compare by project type the range of embodied carbon that's been reported through LCAs for buildings that were able to give us their data. So what you're seeing here is, different types of buildings, office, education, et cetera, and these ranges of embodied carbon, which is kilograms of CO2 per meter or square foot. And once we could do this, we could now understand a starting point. So on any project that we build, we can baseline an embodied carbon number for that building, and then the next step is, again, to work towards reducing that. So our next step is something that you saw a little bit about up on the screen earlier. Now that we could benchmark it, how do we actually quantify and reduce it? So just, 6 months ago now, I'm trying to remember when it started, Skanska decided that we were going to create our own embodied carbon and construction calculator, making it very useful for ourselves first, but what we came to realize is that it's something that is necessary in the marketplace. So I'm just going to walk you through a few of the slides of how this works. You start by, I guess I should step back. The other things that we learned about this when we started to try to quantify and benchmark ourselves is that the tools that are out there are wonderful and necessary tools, but when we tried to actually get to the baseline data of what those numbers included per material or building, we couldn't understand or compare them to each other. So if you use Athena or Tally and compare them to each other right now, for the same exact building with the same exact quantities, your numbers are going to be different because they're using different sources of data to get to those calculations. So one, with what we're trying to do, we're trying to basically be transparent about that, and I'll walk through what we're using. So it's transparency, and the second thing is access. So as a contractor trying to do this work, we can't use Tally right now because it's based in Revit. So that tool is not available for us. Athena is out there, but the way that you input quantities is also not something that I, as a contractor, can just take my estimate and input data into. So ease of access and then open source. It's free. It's going to be free to everybody, and anyone can go create a login and use the tool. So it starts by starting a project. So we start a project in the tool. And then this is I love this. This is live. Phil, our data developer, is downstairs if you want to go demo this right now. But the way it works is that you can input anything you know about a product by category, and it will go back and feed into your project benchmarking site. but you can search by product name, by what you know about your concrete. So you might not know anything, but you put your project in there, so it's going to basically average any concrete with an EPD and a radius to your project and give you those conservative and best practice marks. If you know your PSI and different things, you can actually whittle it down, and you're getting an EPD list that is actually specific to that mix. And this is a little bit of an eye chart, but you can see for a 5,000 PSI 28-day mix with a 5% max SCM, which we talked about, there are 691 EPDs in the database that we're pulling from, which is that number over there, and it gives you a little graphic that shows you the conservative kilograms of CO2 and a best practice, so you know the range. You can then go and actually, oops, that's the wrong slide, but you can then go and actually select a specific manufacturer, supplier's EPD, and have that go back into your project. So you're using that specific concrete mix and supplier to feed the information back into the benchmarking study for the project. And this is just a way of how we're actually quantifying and showing the data. So this is for a tower that we put into the system just for the substructure and shell. But you can start to see that on the left or right, the big blue line is basically the conservative and best in-class numbers for the overall embodied carbon of the building, and then it goes back to every single component that you put into the system to show you kind of that best practice and conservative estimate. So we're piloting this tool right now. I'm happy to announce that Microsoft, one of our clients, is helping to fund this, hosting it on Microsoft Azure, and also piloting it on their 72-acre campus. So we're going to have 18 buildings in the system in the next couple of years, but we're also opening this up to other pilots in the public in the next 6 months.
Great. Thank you, Stacy. You advance the slide just 2 times, and Bruce. Yep, thank you.
I'm a one-trick pony, one slide. Am I on? Is that on? Yes. There we go. Oh, that over there. Well, my claim to fame here is not as knowledgeable about LCA, because other than some very crude ones that I hacked out 15 years ago with no methodology that I knew of, because there weren't any at that point. So I have some appreciation for how hard it is to do and how bewildering it can be, even perhaps for some of you sitting here right now and looking at some of these charts and graphs that we've been showing you. But my perspective, somewhat from the outside as a practicing structural engineer, it's 40 years now, is that it's the Wild West. It's all very much a lot of dust in the air, and we don't have an agreed upon methodology. I really like what Skanska is doing, an open source thing, that hopefully we can arrive on an LCA and EPD methodology that is comprehensible and easy to use for everybody, because it has to get there. And as we as an economy get more facile with big data and managing it around and lumping it around, it'll get to where just on your smartphone you can make good, effective, smart decisions about carbon, both operational and embodied, as you go along. Well, as Will mentioned, we just published this book, The New Carbon Architecture, Will and myself and 18 of our friends, and we're very pleased about it and proud about it, and I hope you should all go buy 7 or 8 copies and give them to your family for Christmas. And my announcement of sorts, Ed sort of mentioned it this morning in his keynote, is that we recently received a grant from the Bay Area Air Quality Management District to write a low-carbon concrete building code, which isn't the sexiest thing in the world when you're going out and trying to raise money or anything, but it's this huge target. Embodied carbon, as Kelly said, is mostly in structure and enclosure, and then it's mostly steel, aluminum, and concrete is the big one all over the world. And the stars have aligned in the sense that here in the Bay Area, all the ready-mix suppliers and most of the structural engineers have been doing low-carbon concrete mixes, and we have a track record, and we're used to it. And we're trying the new technologies that are coming out, like Carbon Cure, where you inject CO2 into the mix and get better concrete and then store carbon, or Blue Planet, that's taking old bits of broken up concrete and coating them with basically artificial limestone, where they pulled the carbon out of the emissions from a power plant. It's just the beginning of the ways in which we will pull carbon out of the air and use it to build with. There's a whole other conversation we could have about photosynthetic architecture, using mass timber construction, and straw bale construction is growing into a whole new world of straw and agricultural byproducts in construction. But the concrete thing seemed like a great place to start for writing something in the building code to address embodied carbon. Our friend Ryan Zizzo, are you here? Wrote a great paper recently surveying the whole world. And all over the world, there's all sorts of green standards and papers and documents. Cal Green of California, USGBC, the LEED standards, they all say, it'd be a nice idea if you didn't use so much cement. But there's nothing in place anywhere yet that's enforceable that can say you must keep under a certain threshold, or something that a building official can enforce. So that's what we're setting out to do, and within the next year, running with the code cycle here in North America, we will have this low carbon concrete building code. And everything is in place to be able to do that, in the sense of, we have a sense of what sort of range of embodied carbon should you have for different strengths of concrete. So what should be the limit that we impose on people? And the technology for making low carbon concrete is here. It's not an added cost. It's often cheaper because you're using less cement. It's the most expensive part of the concrete. So it's really kind of exciting. We're working with Arup and all of their engineers, with Central Concrete, a very progressive outfit here in the Bay Area. A lot of people are going to be involved, but that's my big project at the moment. And as dreary and geeky as it is, I'm really excited, because the concrete we pour in my little Marin County north of the bridge, or Alameda County, or even San Francisco, is pretty trivial. What we hope to do is write something that can export and go viral and be adopted by other towns and counties and communities around North America, but ultimately leap the ocean and get to India and China, where 80% of the world's concrete is going to be poured for the next 20 years. I'll leave it at that.
Great, thank you. So I have a follow-up question for each of our panelists, and I'll start with Kelly. So we know that measuring the embodied carbon starts with understanding the impacts associated with a benchmark building. So in terms of whole building life cycle assessment, how do you approach benchmarking to know that your buildings are actually less carbon intensive?
Yeah, so there are basically rules, and not all of them are really codified, but your reference building needs to be a representative of the building that you're looking at. And there's a great guide, the ASCE SEI guide to the reference building document that we wrote inside the SEI Sustainability Committee, that gives you a guideline of what your reference building should look like. For example, some giant, Salvador Dali looking reference building is not comparable to a generic MOB. It needs to look exactly like your building. It's just you're using baseline information. So for concrete, for example, you would be using the NRMCA EPD. You can use the actual regional average EPD information for your area, and that's what you would be comparing your mixed designs against when you optimize them. You look at the average EPD and you reduce your mixed designs from there, and then that's your baseline. That's like one generic example.
Great, thank you. Question for Stacy is, it looks like Skanska is developing a bunch of really great tools. And so my question is, how do you foster knowledge sharing related to tools and best practices within your organization?
That's a good question. So there's a couple of ways, and I think this is just part of my personality, but it's just doing it. So one of the reasons that we're setting up this tool to allow estimates to just basically be scraped into it is I can basically take any estimate from any pre-construction department of Skanska, output their embodied carbon footprint back to them, and then it just becomes a part of what they see. So instead of talking at them and trying to explain what all this is, the first thing is just giving them information and having them ask questions about it. So that's step number one, is kind of we're going to infest our whole organization with embodied carbon information for this initiative. The second is really for them to understand the impact and the potential for change, that they actually have a say in how this all happens. And that's in pre-con and in our site side of the table. We can, just by asking questions around concrete and telling a supplier that we are looking at procuring concrete from, reduce the emissions by up to 20 to 30% of that mix, just because we're asking the right questions. And so that's really giving the power to even the project engineers that are dealing with these folks to ask the right questions. They shadow me, we go do it together, or we sit down with a concrete supplier and do that. So the empowerment part's really important, so I can actually see the difference and the change that they're able to impact because they're touching that material.
Great. And then a question for Bruce is, your experience with now policy, and I guess the question is how do you convince stakeholders and even government institutions that this is counting carbon is worth it?
I was hoping you were going to tell me that. What did you say? That's a good question. That's a good question. Well, that's why we wrote the new carbon architecture, or I was very intent that it not be a geeky engineer book for those of us who are already carbon gearheads talking about this stuff, like my very distinguished colleagues up here, but rather get the word out with this excited message that, wait a minute, this matters a lot, and the built environment is a place where we can sequester a lot of carbon, because part of the global climate picture is reducing the emissions and then getting it out of the air and burying it somewhere. And of course, the number one place to bury it is in the ground, is in soil. But the built environment is by far the largest artifact of modern humanity, and it's the place where we can store a lot of carbon. So as we get the word out to people that the way you live and work and where you live and work matters, and it can be part of a global solution. It's a long stretch, because it's hard to, like after this event we had in New York, went out to dinner with my sister, lives in New York, and she just kind of exploded in frustration and anger. Well, what am I supposed to do, right? And that's the feeling of a lot of us in here, even a lot of us who are doing a lot. What am I supposed to do? And I think that as we get the word out to people that your lifestyle and the way you live and the way we build our buildings and maintain them matters a lot. And when we can shift as a culture, obviously with the present administration in the White House, our culture is in kind of a different place, seemingly. But on the other hand, I keep looking at the fact that Franklin Roosevelt authorized the Manhattan Project, and only 2.5 years later, we had an atomic explosion. When we set our minds to do something, we can get it done. So that is the big question. How do we shift the culture to where people, not just people in our profession, although there's plenty of those who remain to be informed and converted and excited, but just the culture at large, that we can all be part of a solution. And that's something we can all take on as our message.
And I kind of want to you bring up a great point, and so I want to ask both Kelly and Stacy too, how do you convince building owners that do have the ability to make those decisions and make real changes, how do you convince them? Because they're your stakeholder that you're serving.
Yeah, that's the challenge, right? First, I have to be in the room with the building owner, which I don't always get to be. But then I think you let your passion drive you. It is really incredible when you take a passion-driven approach and you educate people and you tell them that you have some simple solutions. I mean, I think bringing simple solutions to them, the lowest cost solutions first, and then building on from there as you begin to bring them over to your side. It can be difficult, but I've made progress on building owners that I never thought would come to my side, essentially. I brought, for example, the technology Carbon Cure to a project that really didn't have extreme sustainability goals. They certainly weren't looking to do anything new and exciting, and they were very hesitant to consider it, and they really had no motivation. But I brought this solution to them, and it's part of many solutions that we need to look at, but you won't get anywhere if you don't try at least. So you've got to first try.
I'm excited for this question because I've made progress in this category, and I'm excited to share that with the ownership story around this. So the one thing I will say, doing that benchmarking exercise where I can now go to an owner, and I will say that it's much easier with owners that have already bought into carbon on the operational side, because carbon is a part of their language and something that they're familiar with. They're used to counting it, they're used to reducing it, they're used to telling the whole story around that side of the equation. So it's gotten easier because carbon is no longer a word that a lot of these savvy large owners don't understand. But now that I can actually benchmark, even though it's not perfect, I can go into interviews with clients, I can go into first meetings and say, hey, did you know that based on this square footage, you're going to have, 1 billion megatons of embodied carbon that you're putting into the ground? And just by saying that one thing based in some essence of fact, because I have a data set of 1,000 buildings, makes their eyes kind of bug out because no one's told them that before. No one's put it into a number that they can actually look at and leverage it against the operational side of the equation. So I did that in an interview for Microsoft. Now I can say that out loud because they're announcing they're using this tool that we're creating. I gave them their potential impact for their campus project, which is 18 buildings and 72 acres of construction. And I showed that against their operational numbers. And we ended up winning the job. I got to do that in their interview. And sustainability was actually a part of the score, which is also not always the case. And once we won it, they said, okay, we want you to tell us how to reduce this. So it was literally just trying. It was getting up there in front of them, not knowing if they were going to care, and just saying, hey, here's your potential impact. If you want to do something about it, let me know. And then that's also just happened last week with a client that's also an international, global, very large company, where we're not actually building anything for them, but they've heard about this, something about carbon that we're doing. So I sat down with this VP for 15, 20 minutes in his little schedule. You get escorted in and out. And I asked them what they were doing on carbon. It was all operational carbon, the whole story. And I said, well, have you heard about embodied carbon? And he said, well, what's that? And their portfolio is probably the largest portfolio in the world of buildings and data centers and all sorts of things. And I said, well, here's what it is. And he said, well, just give me a list of the lowest emitting products, and maybe I'm just going to go tell them to switch that one out for this one because you can give me a list and tell me which one's better. So really, I think there's two lessons. It's just saying it and being able to quantify it somehow, however you can, whatever you use, so they're understanding that impact, especially for those that are carbon savvy in general with operational carbon. And then second, it's really just being there to help them reduce it, and that's data. And I am not a data person. I'm a right-brained architect that now works for a construction company. But I'm so excited about having data that gives you numbers that you can then quantify and reduce against. I think that's something that's been missing when it comes to embodied carbon. And I really think that there needs to be, and I'm spiffing a little bit off this question, but for code and policy too, there needs to be an ASHRAE of embodied carbon with an embodied carbon use intensity that becomes just code, just like the operational side of things. And I think that's how we can start to actually invest change. Use the language that people already know and start talking about this.
Great. Thank you. Yeah, I totally agree. So, the conversations about carbon typically center on this operational side, and you've heard three perspectives where really our main viewpoint is in the embodied side. And so you've heard a couple of our panelists talk about tools that they use to count embodied carbon: Athena, Tally, Skanska's internal carbon calculator.
External. It's not internal. Please don't. It's EC3. It'll be everywhere. Yeah.
It will be open
it's not
access.
internal.
Yeah. Is it open access now?
In March.
In March. Okay, great. And we're going to come back to resources at the end of the hour. But at this point, I wanted to pause because we have some time for you in the audience to get engaged in the conversation.
Great, thanks, Will. We do want to get all of you to have a chance to speak and to participate and to create what this is as well. So once again, what we'd like to do is take about 2 or 3 minutes, stand up, find someone you have not spoken yet with this morning, and spend a couple of minutes. What did you hear that was remarkable, insightful, stunning, amazing, dumb, something you want to know more about, something you disagree with? Stand up and find somebody to talk about it with right now. You guys are fantastic. And I haven't even met you, Kelly. I'm Andrew. I got lots of family in Atlanta, Georgia, and my nephews, cousins, my sister lives in Ringgold, aunts, uncles, South Carolina, Greenville, South Carolina as well. So I've been through Atlanta a lot. I'll be back there for Thanksgiving.
It's pretty in the fall.
It is.
My kayak, what's the big river real close from south to Carolina to Georgia, the Chattooga?
Guys are from
College. Both are on kayaks out of Denver place. Spring break kayaking down the East Coast. Chattooga. Yeah. My first encounter with that part of American culture, which
I think you could probably blame Michigan as much as Georgia for that. Yeah.
No, I'm actually from Florida.
No cost or reduced cost.
Yeah.
Northern Florida is southern Florida.
Yeah, I'm from Tampa, which is a big melting pot of everything. Tampa. Yeah. My dad is a Cuban immigrant, like everybody in Tampa.
I wouldn't have guessed that.
So I think we'll let them talk for,
Just a couple more minutes and then pull them back. Yeah.
and I guess you do comments first and then questions, or is it?
No, it's basically, it's whatever. So anybody, if you got a question, you got a comment, you got a suggestion, just get several things out into the air here. And then you guys just do whatever you want to with it.
Okay.
That's totally up to you.
Sounds good.
Okay.
Yeah, we'll bring it home strong.
So you're an excellent session host, by the
Oh,
way.
thank
You're doing
you.
a great job.
Thank you. I feel like I'm fumbling and like.
No, there's a really nice flow that you've got going on here. And, I like the order that people are talking in, and I like what they're saying, and
Good.
they're all just, they're all eloquent and thoughtful.
Yeah,
It's really
I
good.
forgot to mention that we had to pinch hit Bruce's pinch hitting because.
Oh, he is? Oh, yeah.
Brent is stuck in the
Yeah,
hurricane.
right,
Yeah, so.
right.
But-
We could blame that on climate change.
Yeah, I know. I thought about making
Yeah.
that comment too. But Bruce is always so eloquent.
Yeah,
And he has his
absolutely.
experience.
All right, I'll call him back. Hello, everybody. We're going to call you back into the room now. So if you just conclude the last sentence or so and then have a seat. And we'll get going in just about 21 seconds.
20 seconds.
Now it's 18 seconds.
To blast off.
So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Great. So hopefully you've heard a little and shared a little about some impactful things that have been said, or that you maybe want to know a little bit more about. So I encourage you to, those of you who have a comment that they'd like to share, please go ahead and do so.
I think we've got 2 people with mics running around, so just jump up, wave your hand, and somebody with a mic will grab you right there, and we've got one right there. And then other people, please be thinking about jumping up. Go ahead.
Yeah, Peter Rumsey from Point Energy Innovations, and I'm just curious, has anybody been looking into the embodied carbon for batteries? Because that's coming on big right now, and I haven't heard anything about that.
Okay. Storage. And then over here, who's got the mic over here? Maybe I'll do that. Oh, you've got it right there. All
Hi.
right, go
Years
ahead.
ago, I was involved in helping develop standards for collaborative for high-performance schools, and talking about replacement for cement with fly ash and slag, and we got into conversation about toxicity. And can this be exposed to children, exposed to the environment? What do you do? Do you have to only use it for foundations and not above ground concrete? And just what are your thoughts on that?
Great, thank you. And just remember, we're asking, tell us something that you heard that you found was particularly insightful or thoughtful or remarkable, something to report. Who else? Right here.
Hi, Angie Brooks. I'm chair of the COAT committee for the National AIA. And what I learned today is this great tool to actually measure carbon. So we're actually working on a toolkit at the national level for all firms to use based on the top 10 measures. And it's linked to tools so that architects can actually quickly kind of see how much carbon they're using and design better buildings. So that's great. And we're going to be using this tool when it comes out in March.
Fantastic, thank you. Right over here.
Hi. Oh, yeah, sorry. Andrew Lee with our International Living Future Institute. Yeah, I really appreciate this discussion because I think we all look at embodied carbon and we say like, oh geez, I really need to know more. I need more data. I need like to have that assurance that I can, really back what I say up with metrics. But I really appreciate that we landed on a place that we do need better data, we do need better tools, but we still have to talk about it directionally. We still have to talk about it like, this is how we're going to use this information to make decisions. Because at the end of the day, that's what matters, is the impacts we can make, the small changes we can make in design and construction. So, love that.
Thanks very much. Let's have one more person. I think we've got someone right here.
Yes.
And then we'll turn it back over to the panel.
Peter Turnbull with Pacific Gas and Electric. How do we use the tool set to address the existing building stock and provide some guidance with the however many billions of tons of concrete and steels already in buildings? How do we use the tools to address that?
These are excellent comments and questions, and ones that we get, I think, a lot. And the toxicity question, I'm happy to answer that. I'm a cement chemist, so I can definitely help answer that question, but I don't want to take time away from the panel. So two things I do want to address. One is on data, and one is on existing buildings. So I think I'm going to have the panelists respond as you feel compelled to, about challenges with data and challenges how you're overcoming that.
I'll just address the data one right now because with whole building lifecycle assessment, how we're using it right now is largely comparative. So you're in one tool and you're looking at making an improvement on a specific building at a specific point in time. And so that's how we're largely using the data now, and I do believe that that is very useful and can be used right now. Now, do the actual carbon numbers mean anything? That's debatable. That's what we need to get to, obviously, because eventually what I want to get to is speccing a max kilogram per CO2 for my concrete instead of a required cement replacement or a specific mix design. That's what we want to get to, but it's really difficult right now to do that.
And I'll just follow up on that. I think, so an example of that, when we have access to data and real numbers, I mean, quite honestly, what we're trying to do right now is still have the tools that are out there being used because they need to be, right? Not everyone's going to use Skanska's tool, but we're trying to get more accurate data. And I think what we're doing on the Microsoft project potentially is setting those targets per material category in our spec and piloting that to see how that works because we have accurate data for our region on those numbers. So again, it does get back to the data and understanding those metrics and benchmarks, and then, how simple can you make it also? I think that's the other thing that has been a challenge for us is simplicity in some of these tools, and just how you can just look at that specific thing that you want and find an answer and result and compare simply, because owners need simplicity. I think us as designers and contractors and engineers need simplicity because we don't have the time all the time to get into the nuances of everything. So simplicity, I think, around data.
And for those, if anyone is a product manufacturer in the room, these folks rely on environmental product declarations, data that is generated that is product specific to help in the decision making. So those are the generators of the data that have third-party verified information about building products that we rely on. We definitely rely on, and there are databases that are being built. I know 5 years ago we weren't having the conversation about EPDs. There's something we didn't talk about either, which are HPDs, which are health product declarations, which get at the environmental impacts associated with human health and toxicity that are equivalent to the EPDs, and some product manufacturers have those as well. So the other question I want to pose to the panel is on existing buildings, projects related to existing buildings, your perception of the importance of existing buildings in saving carbon.
I'll say something to Peter's question. For the very reason that most of the embodied carbon is in the structure and the enclosure, that is one of the two big arguments for retrofitting existing buildings. Number one, stop them from bleeding like stuck pigs, energy into the sky every day. But also recognize them as a resource. I've spent a lot of time working with the so-called natural building community with straw bale building and earthen building and so on, which is a barrel of fun, but wrestling all the time with how does that scale up, how does that become relevant to people moving to cities and to the explosion of growth in India and China and so on. And one of them is that the basic principle of natural building is you use what you already have, use what's lying around in the landscape nearby. You don't process things too much and you don't transport them very much. And what's around us everywhere to be used are buildings, existing buildings. If you tear something down, we all know stories about people tearing down an old building in your town and rebuilding something new. Maybe it's a LEED Platinum building and it gets a lot of great press and everybody's very excited and it's all very fun. But probably from the climate perspective, you would have been better off fixing up that building you already had. I'm sure there are exceptions, but with the studies that I've seen, if Larry Strain is here, raise your hand, because he's the guy to talk to about it. Larry, are you here? You're not. But that's the gist of it. That's the twofold argument for fixing up existing buildings, not just to fix their operational emissions, but by the fact that that represents something we've already spent. It's money we've spent. It's carbon we've emitted. If you tear it down, you're going to emit a whole bunch more building something new, even if it's LEED Platinum. And as to the conversation about fly ash in concrete and slag in concrete, and Will, you may have more current information, but I wrote a book about high-volume fly ash concrete 15 years ago and learned most of what I got from this wonderful elderly Indian professor, P.K. Mehta at University of California, and a very sweet guy. And he addressed that question specifically because he was concerned about it, and people had tested, and they found that when you use fly ash in concrete, as long as there's some cement there, they chemically bond in a way that heavy metals that are present in fly ash get bond, and they won't go anywhere. It was fine, they did very credible tests to determine that, which is kind of just an asterisk now because fly ash is disappearing from the marketplace, and what people are using, mostly here on the West Coast anyway, is slag. I don't know, maybe it's different on the East Coast where you have a lot of coal-fired power still.
We have a lot of fly ash.
But do either of you want to add anything more to that?
I will just follow up with Bruce with saying absolutely about the metals, the heavy metals. It's mainly mercury, I think, that people are really concerned about with fly ash, and they do bond. And I always tell my students that ions don't fly, they swim. So that it has to be wet and submerged, and they have to leach out even if they weren't chemically bonded. And so most concrete in building applications will be fine with fly ash that have heavy metals, that bear heavy metals. So back to the existing buildings comment. Stacy?
Yeah, so there's a couple of things. I think there has to be incentives to use existing buildings, and Seattle's kind of leading the way on this right now because a lot of owners aren't incentivized to keep that building and build on it or make it better, right? It's easier for them to tear that building down and build something new. So there's the awareness again about the embodied carbon component of that, being able to quantify, how much less they're going to emit if they use that building. But Seattle just rolled out an incentive program where if you do retrofit an existing building to a certain efficiency, it's a very high efficiency, you actually get building rights that then another developer can build where they're going to build a new building anyway. So I think incentivizing the existing building stock to be used in a way that is smart, we'll see progress that way. It has to be done right. But it's also, again, the education part and just giving them those numbers.
Great. So last question for each of the panelists, if you take 1 to 2 minutes to each answer this question, is about resources. So some of folks in the audience may have just learned the term embodied carbon. Some may already be apt users of different carbon accounting tools. So what are your top resources for folks to really dig into tools that will help them count carbon on their projects?
So Kate Simonin's book, Whole Building Life Cycle Assessment, that's a great book if you're just getting introduced into whole building life cycle assessment. And then the ASCE reference guide to the reference building, that's a really important book as well. And then of course, Carbon Leadership Forum's website, there's lots of good white papers there, lots of good introductory material. And I'm sure you'll hear this plugged throughout the conference, but join the Embodied Carbon Network. I don't know the website, ECN. If you just look up Embodied Carbon Network, I'm sure you can find it.
Yeah, I was just going to second that. So in the Embodied Carbon Network, there's task forces for each kind of category of practitioner. There's a construction one, a materials one, an advocacy policy one. So there's ways to get in there, and just that's really a place to learn. So it's a group of folks that get together and meet and talk once a month to share information. There's a base camp site where you get you can choose how much you want, but you can get a ton of information and resources on almost a daily basis. It's moving so fast right now. There's a new article or book or story or something out there almost, daily, it feels like. So I definitely, the ECN is a great place to start to learn. And then for tools, I think it is using the tools that are out there. Athena and Tally are there, and they're available for you to start quantifying. We'll make ours public when it's public, and then books. Read Bruce's book. If you're trying to get someone else to understand carbon, read that book. It's a great book.
Yeah, and buy a few more copies. But that was exactly the intent that we had in putting it out. Again, is because everything that everybody said the last 5 minutes is true. And but if you're not quite in the mood for the sip from a fire hose experience that we all have all too often these days, the book is a nice, relatively easy read. I said let's keep numbers out of it as much as possible. Pretty pictures, there's cat videos, everything, just to make it as, not quite like that, but to make it approachable, both for building professionals who are new to this subject, but also for the public at large to get around the idea. And then once your next step is, as Kelly and Stacy. I'm going to pay for that, yeah. There's a ton of information. The Embodied Carbon website and the ASCE thing that Kelly mentioned are great.
Can I make one last plug?
Yes. My brain is fired.
Talk to your structural engineers about embodied carbon. Have that conversation with them. Ask the question. If they don't know the answer right away, then send them home with homework. Make them learn. And if they don't, then find a structural engineer who does.
Well, I'm acutely aware that I am the last thing that stands between you and lunch, so we're going to end right on time. I want to thank the panelists for all of their insights. I know we try to pack a lot into 1 hour. 1 hour is not enough to talk about things like policy and the USGBC and the Living Building Challenge and how that's moving the needle with getting people to do things, natural building materials, getting them through codes and through standards to be able to use more of them. These folks are knowledge resources for you, so feel free to pick their brain at lunch or in the breaks or even after this workshop. But I want to thank them. Let's give them a round of applause.